Hi, I'm Brian from Simply Brian Enterprises and welcome to my channel. In today's video, we're going to be looking at the conclusion for the homework for TopTechBoy's Raspberry Pi class, lesson number 18. Now, before we begin, I need to make a couple of housekeeping items. First and foremost, in my previous lesson, I forgot to give credit to Mr. James Lewis of AddOhms.com and baldengineer.com. He is the engineer who helped me to understand millis through the various demos on his website. And I'm going to leave a link to those below. If you want to learn a little bit more about millis and how to do some kind of pseudo multitasking type things on Arduino, really fascinating stuff. He's done a really nice job. And so I want to give a shout out to him for his help with that. Secondly, I have learned the hard way not to make multi-part videos on YouTube. I've heard from other YouTube professionals that multi-part videos for some reason just don't get the views of regular single topic videos, and I've definitely seen that. For some reason, the view count on my part 2 video was significantly lower than any of my other videos and has something, I'm sure, to do with the YouTube algorithm that only the YouTube engineers understand. And quite honestly, I don't really want to play the game, so this will likely be the last time I try to do a multi-part video, unless it's something that just can't be said in one reasonable length video. Finally, I need to make a change to my code because in the summer time frame when I wasn't recording videos, we adopted ourselves a cat. And so cat talk is now allowed in this house. And so because of that, we have to repurpose the long-standing cat talk button and give it a new job. So we'll be seeing that in the program in this conclusion video as well. So with all that said, let's go ahead and take a look at the program, and then we'll take a look at the code, and then we'll wrap up lesson 18. So I'm going to go ahead and start my program. And once again, I've got my little spaceship in VPython once it loads up. And you'll notice over here, I have my coordinates and I have a delay counter being printed out. And when I move my ship around, you'll notice that the delay counter changes. And I can, once again, I've got my X and my Y. I've got my Z axis. It's coming towards us. It's flying away. And now what we saw in the last video is when I hold down what was the cat talk button, the program code execution stops. Well, now with the new design, I can continue running the program even though the button is depressed. And now when I release the button, we find out it's not the cat talk button, it is the alien smash button. We just lost the left wing of our spaceship, and now we lost the right wing, and we destroyed the ship to end the program and release the pins. So without further ado, let's close this out and take a little look at the code and what changed. I connect that out. There we go. So Keith made a mention in my part 2 comment about using time.monotonic, and that is exactly what I've done. So in the time module in Python, there's a function called monotonic. And what this does is it is just a counter of time. Unlike the Arduino millis counter, it doesn't have really a true source. It's rather arbitrary, but it just counts upwards from a point. And for what we're doing, it's good enough because we don't necessarily care what the number is. We just care the changes every time we expire a counter. We just want to grab the latest timestamp. And as long as there's a timestamp available, we don't really care what the value is. Now, monotonic is displayed as a floating point with the full seconds as a whole number, and then out to 8 decimal places, I believe, which would make it microseconds. And so to convert it to a millisecond counter, what we have to do is take the integer value of time.monotonic times 1000, and that basically gives us the equivalent of a millis function in Arduino. So here we have the cat talk pin has become the alien smash pin. And we're loading up all our pins, writing out our ship in VPython. And we are adding state. So we have the alien smash state of false. And we also have the previous counters. Just like we did in millis, we have a current timer and we have a previous timer. And so we've got to set up our previous timers. And then we're also going to define our delays as variables. If you remember, I had a 200 millisecond sleep statement in the joystick section of the code. So basically, no matter what, it would wait 200 milliseconds every time the stick was moved so that it didn't move too far, but move quickly enough. And by bringing it into a variable like this, I found that actually 150 milliseconds is a little smoother than 200. And so when we go down into our while loop, again, basically until the alien spaceship is smashed, we will just run this loop over and over and over. So we grab the current time. Again, here's time.monotonic times 1,000. Take the integer of that to get a millisecond counter. Every single time through the loop, we're going to read the value of X, Y, Z, and the joystick push button. If the timer has expired, so that 150 millisecond counter, if it's greater than 150 millisecond, if the timer expired, we're going to read the values from the joystick, X, Y, and push button, oh, and potentiometer. And if there's changes, we're going to write them out to the variables. Then we're also going to, this is where I got a little bit lazy. So if you noticed the output of the coordinates and that delay timer, it was kind of choppy. It wasn't very consistent. The reason for that is I got lazy and I just said, we're going to take a comparison of the current millisecond time divided by 250. So basically every 250 milliseconds, and compare the integer to the float value. And this just basically tells us if we're close to 250 milliseconds. Sometimes we are, sometimes we aren't when this part of the code runs. So sometimes it displays at 250 millisecond intervals, sometimes it doesn't. I'm okay with that because honestly, this is just kind of debugging information. If I don't get it every single time through the loop, I'm okay with that. And then we, of course, every time through the loop, we're going to write out the position of the sphere, the left box, and the right box. Now, when we get down to the alien smash button, this took a little bit of thinking, but I'll try to explain this. So we have this counter of 50 millisecond. So if the counter has expired, we're going to read the state of the button. Now, this is a pull up button, which means most of the time it's going to be true. Now, way up at the top, we set alien smash to false, or alien smash state to false. So if the button is true and the alien smash state is false, nothing happens and it just keeps looping through over and over and over and over and over. If the button state is false, so we do an if true, we have an else statement down here. So if it's false, we're going to set the smash state to true, and we're going to reset the counter. So now we just basically go through every single time. We're going to check to see, well, basically, okay, so every time it goes through the while loop, if the counter hasn't expired, it's going to skip this code. If the counter has expired, it's going to read the state of the button. Oh, we're still holding it down. 50 milliseconds, it's really hard to get a press and release within 50 milliseconds. So more likely than not, it's still going to be held down. So it just comes down here again, sets the state to true, resets the counter. Okay, now I let go. The counter is going to expire. Now the button state is true. And now my alien smash state is true because I did have the button pressed down. So now I have to make an augmented change here because the button state changed. And, or I should say, the button state is true, but the smash state changed. So now we're going to increment the smash counter. We're going to reset the state to false because we don't want it to go true, 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 true. It'll just expire the program. And then, of course, reset our previous counter and then write out that we hit the ship. Then we come down because we're not done yet. If the alien smash counter is, let's see, what is that number? Greater than 0. Okay, so if there's 1, If we hit it once and that alien smash counter is 1, we're going to change the opacity of the left wing. So basically we're going to set it to 0, meaning it disappears. So it's still writing it in VPython, but its opacity is 0, so you can't see it. And if it's greater than 1, meaning that that counter has now been pressed twice, we're going to blow off the right wing as well, set the opacity of the right wing to 0. So now it's just the floating orb. And then once we hit 3, we exit this whole while loop. We come out of here. We set the opacity of all 3 to 0. So the ship goes away. We write out the alien ship destroyed, and we clean up the pi pins. So that was kind of a strange solution to this problem. But going forward, I'm going to be able to do a lot more things with the code because we're going to be getting into more advanced input and output circuits. So think about, we have a temperature sensor that's outputting data on the LCD, and we have a push button and a potentiometer that's making changes as well. We need to track all those individually. We don't want to be putting sleeps in there because that's going to mess up the reading of the temperature. It's going to mess up the writing on the LCD. So we have to make sure our program is constantly running and we're not stopping waiting for user input. So my hope is that all this time investment in lesson 18 is going to pay dividends as we go forward. If you've enjoyed this video, please hit like and subscribe below. Be sure to show this channel some love on YouTube. And I thank you for watching, and I will see you next time. For Simply Brian Enterprises, this is Brian. Thank you for watching.